carbons form rings, and our goal is to be able to name and draw aromatic compounds, both as parent chains and as branches. So benzene is a very interesting compound with a strange history. The chemical was actually discovered by Michael Faraday, one of the about billion things Faraday did. But the formula puzzled chemists for the longest time. An unbranched benzene molecule has the formula of C6H6. If you compare it to the other formulas of chemicals we've worked with so far, that's a very strangely low number of hydrogens. There's an abnormally low hydrogenation level, and when chemists analyzed the chemical, it indicated that all of the carbon-carbon bonds were the same length, even though when they predicted the structure of it, they predicted alternating single and double bonds. So what the heck is going on here? Just to make this story even weirder, at first people weren't even able to figure out that benzene was a ring. And they only did because a chemist had a literal fever dream where they imagined a snake biting its own tail, and he realized that that's what was happening with the benzene. The only way you could get 6 carbons and 6 hydrogens was if it was looped around in a ring, because this was pre-electron microscope time, so they couldn't just look at it and take a scan of what the structure was like to try and help them predict it. So literally the structure of this compound came to someone in a dream. But even after that, the single bond, double bond confused people. But we can explain it, and we can explain it through a process called resonance. So what resonance is it's a kind of delocalization of electrons from their orbitals. It allows electrons to jump from one orbital to the next. Now, that might sound like it should be electrically conductive, but it's actually not. What it really means is that the electrons have spread out more, and that actually creates very unique structures. So here are 2 possible ways of drawing dimethylbenzene. And what you see is that it could be either one of them. Is the double bond between carbon 1 and carbon 2 with the 2 methyls, or is it on the outside and the single bond is between the 2 of them? Well, if you draw each of them out, you'll find that they're both valid configurations. So which is correct? Well, the answer is both and neither. What happens is sometimes chemists describe resonance as 2 different forms being simultaneously present. It's nothing quite so science fiction as that, though. What it actually is that you have some electrons that are able to spread between orbitals. The way the orbitals are interacting with each other, they're all very close together, so the electrons can just move around them, and as long as they stay evenly dispersed, they can actually move through those overlapping orbitals. So the real structure is actually closest to that diagram on the bottom that has the circle in the middle. And we can represent benzene either of these 2 ways, with the alternating double bonds or with the central circle. Most chemists do use the alternating double bonds, even though it's not correct necessarily, it is easier to draw. So it is incorrect in a useful way. But what this means is that you don't actually have single bonds or double bonds in the bonds in hexene or in benzene. What you actually have is kind of 1.5 bonds in air quotes, and that's because the resonance bond kind of acts a little bit like a single bond and a little bit like a double bond. What that means, though, for the shape is that all of the bonds are the same, which is why you get them evenly spread out instead of having longer double bonds and shorter single bonds. When we name benzene compounds, there's actually two different ways that we can name it. If the benzene is central and there's branches coming off of it, then we just use benzene as the parent chain. So you can have something like the diagram we had before, 1,2-dimethylbenzene. The benzene in this compound acts as the parent chain. If there's more than one branch, then we just number them off like we would with cyclic compounds. Make sure that the numbers are as low as possible, and if there's more than one correct way to make the numbers as low as possible, give priority to whatever's alphabetically first. The alternate way of naming a benzene is we can actually name a benzene as a branch. And when we name benzene as a branch, we give it the name phenyl. Sounds similar to our methyl and our ethyl. It ends in that YL. But phenyl specifically refers to benzene. And yes, it might make a little bit more sense if we called it benzyl, but we're stuck with phenyl as it is. So we can look at a compound and see that the benzene is actually a branch, and we would use a phenyl name for that branch. There are also a lot of other benzene compounds with specific names. This is a sampling of them. You do not need to know them in Chemistry 30. But there are a whole bunch of different ways that we can name compounds that use benzene as their base, and it does go beyond just having a single benzene ring as part of that compound.